Number systems. Our today's topic is octal number system. Today we will concentrate on decimal to octal number conversion. We know that decimal number system is a base 10 system which contains 10 basic symbols 0 to 9. Since it is a base 10 system, its weight values represented as a power of 10. As we move towards the left of the decimal point, the weight values increases, and as we move towards the right of the decimal point, the weight values decreases. Whereas the octal number system is a base 8 system which uses 8 basic symbols 0 to 7. The weight values of octal number system is represented as a power of 8. If we move towards the left of the octal point, then the power increases, and as we move towards the right of the octal point, the power of 8 decreases. Prior to conversion of any number from decimal to octal, we have to verify either the number is an integer, a fractional number, or a mixed number. If it is an integer number, then we have to perform the repeated division by 8 until the quotient is 0. Whereas in case of a fractional number, we have to perform the repeated multiplication by 8, and in case of a mixed number, we have to perform both the operations separately as mentioned, and then we have to combine the both for the final result. Now let us discuss with examples. The example 1. Here we have to convert the decimal number 261 into octal. Since it is an integer, we have to perform the division operation by 8. If we divide the number by 8, the quotient will be 32, the remainder will be 5. The 5 in decimal is also equal to the 5 in octal system, and this 5 is known as here the least significant digit. Again, when we divide the 32 by 8, the quotient will be 4, the remainder will be 0. The 0 in octal system is same as that of the decimal system. Now when we divide the 4 by 8, the quotient will be 0 and the remainder will be 4. This 4 in decimal system is also equal to the 4 in octal system, and this 4 is known as the MSD, or the most significant digit here. So we have to move up. Hence 405 is the octal equivalent of the decimal number 261. Now let us take another example 2. Here the number is a fractional number. So we have to perform the repeated multiplication by 8. When we multiply the fractional number by 8, we get 6.5000. Here we have to take the 6, which is an integer. Here this 6 in decimal system is also equal to the 6 in octal system. Now this 6 is known as the MST. Next we have to multiply the fractional part 0.5000 by 8. In this case the result will be 4.0000. Here the 4 is to be taken out as it is an integer. Now the 4 in decimal system is also equal to 4 in octal system, and in this case the 4 is the LST, and we have to move downwards. Hence the number 0.64, which is the octal equivalent of decimal number 0.8125. Let us take another example, the example 3. Here the number 2648 is also an integer number, so we have to perform the repeated division by 8. If we perform the operation, then we will get the quotient as 331 and the remainder as 0. The 0 in octal and in decimal is the same, and it is the LST here. And if we perform the division operation again, then we will get the remainder as mentioned. Finally we will get the quotient as 0 and the remainder will be 5. This 5 will be the MST. Now we have to move up or read up to get the octal equivalent of this decimal number. Here 5130 is the octal equivalent of decimal number 2648. Let us take another example 4, which contains the integer part as well as the fractional part. We have to consider first the integer part. Hence we have to perform the repeated division by 8. If we perform this division operation, then we will get 1 as the LSD, and the next operation is to be continued, and if we perform the division operation, then we will get ultimately 0 as the quotient and 7 will be the remainder. This 7 in decimal system is also equal to the 7 in octal system. This 7 will be here the MST, and now we have to read off. So 75031 is the octal equivalent of decimal number 31257. Now for the fractional part, we have to perform the repeated multiplication by 8. Here we have to multiply the fractional part by 8, and if we do that, then we'll get 5.000, and then we have to extract out the whole number or the integer part, that is 5. This 5 in decimal system is also equal to the 5 in octal system, and we can write 0.5 is the octal equivalent of the decimal number 0.625. Hence, we can say 75031.5 is the octal equivalent of decimal number 31257.625. This is in brief about decimal to binary conversion. For further details about the number systems, we have to continue to number system lecture 6. Thank you.